G'day, it's Prezzo here, back in the shop, and can you hear the kookaburras outside? They're really noisy today. I'm just going to talk over them. This is another episode in building a replica or an Art Deco inspired digital clock based on an edge-lit Lixie display. And in this episode we're going to look at nickel plating this brass bezel, which is a decorative feature on the front of the clock. Now I am doing two clocks, that's why there's two of these. This bezel here has been polished. This one, in the last episode I showed the manufacturing of this, and this one has just been sanded with very fine wet or dry sandpaper. It still needs to have the mirror finish put on that prior to the nickel plating process. Now a lot of people have commented and said, why don't you just leave it brass? It looks nice. And yes, it does. I love the polished brass look. But unfortunately in the 1930s, craftsmen were starting to experiment with modern techniques, and brass was a little bit Victorian for some of the craftsmen back in that day. So things like nickel plating and chrome plating and even platinum plating were being explored as decorative finishes for metal. And it's very uncommon to find Art Deco based designs using polished brass. And the other thing of course is that brass does oxidize very readily, and you'd be forever polishing this to keep it looking that way. So we are going to nickel plate. In the first part of this video I'm going to demonstrate the process I use for polishing this, and then we're going to look at the nickel plating process itself. Okay, let's get over the other bench. Here is one of those frames which is to about 95% of where I want it to be before I start nickel plating. This one is still in its fairly rough state, so it's just been draw filed and given a general flatting down with some coarse abrasive. Now I'm going to let you in on a little secret about polishing metal, and the secret is that there are no shortcuts, at least for a DIY enthusiast anyway. The method relies on using gradually finer and finer methods of abrading away the metal. So in my case I started with a file, in this case just a fine needle file. That took off the worst of the high spots where the silver soldering process took place. I then moved on to using a fairly coarse woodworking abrasive. This is 240 grit paper, and I did that on a sanding block. I then moved on to this is 00 grade emery cloth, and with that little block there it allows you to get into these areas where the joints have been made and sort of get them relatively flat. I then moved on to this, which is 600 grade wet or dry, and I did that dry, and as you can see this is well used and well filled with metal powder, so it tends to just take the high spots off. I've also got one of these little abrasive rubber blocks which are good just for doing odd areas where you might find a deeper scratch that you missed in an earlier stage. I also have this, which is 800 grit wet or dry paper wrapped around a stick, one of these lolly sticks, and it allows you to get into inside edges and close to corners and so on. And finally I use a Dremel with a felt wheel, and that in conjunction with a metal polish. In this case I'm using a cream because it doesn't spray everywhere when you hit it with the felt wheel. That tends to put the final polish on it. Now although that looks polished, if you put that under a scanning microscope you still will find that it'll have a series of peaks and valleys. It's just that they're so close together, and with the diffraction of light it looks polished, but it's, you know, it's a relative thing. It's there's no such thing as a perfectly polished surface, at least in a home workshop anyway. Now I'm not kidding, this took about like 6 hours to get to that stage, and like I say, it's still got defects in it. The defects are in the joints. Now I'm trying to get this in a light where you can see it. I put an arrow there, but there's a tiny little crease where the joint was made, and I need to get that out. The method I'm going to use, I'm going to fill that with a soft solder and then polish over that. And you can nickel plate over soft solder. So there's a test piece I did on a piece of copper. I drilled a hole in it, I filled it with solder, and I've nickel plated over that. And although you can see it really clearly there, you can see the solder, it has nickel plated over the top of that. And part of the reason why you can see that so clearly is that the solder is softer than the copper, so as you polish it, it tends to polish down lower than the surrounding copper. But for small defects, it's probably the best you're going to get to try and fill them. So right at the end, before we nickel plate this, I'm going to sweat some solder into those little defects, and I'm going to join a piece of copper wire on the back of this with soft solder so we've got an electrical connection. Okay, let's get this one in the vise, and I'll just show you part of that process for getting an area of that polished. Now, I should point out here that these jaws in my vise are not serrated, so I've turned them around so I've got the smooth face of the jaw on the inside, and I've also put masking tape on the face of that jaw there just to prevent, or at least provide, a softish sort of surface to grip that brass, because the last thing you want to do is to polish a surface, then turn it around, re-grip it, and find that the jaws have actually pressed marks into the brass. And I've been finding as I do this that I keep finding little pinholes, and I'm guessing that that's where a little piece of debris has been pushed into the brass while I tighten the vise. So I'm trying not to over tighten, and I'm trying to keep that clean. So if we take this corner here, for example, the first step is to use that little double low grade emery cloth stick and just go over that. And you've got to get the light in the right place and just see where the scratch marks are. And if you notice any little areas where it appears to be rounded over, you just keep working at that until you get that as close as you can to being flat. Now, it's almost inevitable this is going to get rounded over anyway during this process, so don't sweat about it too much. Okay, next I just use the sanding block. This has got the 600 grit wet or dry on it. And basically you have to keep going until you don't see any scratches from the previous process. If you can see deep scratches, it's pointless going any further, because you're not going to get them out with the finer grit that you use after this one. And that's why I say it's tedious and boring and frustrating, because you think you've got it right and you polish it and you see all these scratches appear. You can go around circles or you can go straight, doesn't really matter. Although, so I'm just doing this at an angle of about 45 degrees. And the reason for that is you sort of want to get scratch marks running in opposite angles. It's easier then to see whether you've actually been successful in getting out the previous scratch marks. Alright, this is now the 800 grit wet or dry. I'm just going to finish that in a circular pattern. And finally, we're going to try some of this paste polish. Just a thin smear of that. I don't know if there's any particular brand that's better than any other. Okay, now with the Dremel. And although that looks okay, I mean, it's shiny and it's reflecting light, when I look at this really carefully I can still see very fine scratches in that. Now I can repeat that process with the felt wheel a number of times, and it does get a little bit better, especially if you cross the angle of the wheel. So take it at sort of 45 degrees one way, then go 45 the other way, and you gradually cancel out any of those fine scratches. But if there's any actual damage there, you need to go back to the previous step or back to the first step if it's really deep. And that's why it gets frustrating. You think you got it right, you see a point that you missed, and you've got to go right back to square one and start again. But it's just about being patient. So let's go on to the next bit, and I just do this in stages, just working a short bit at a time. The part that I have in the vise, if I start working outside the vise jaws, there's always a danger that you're going to bend it or crack one of those joints. Now I've already done this with the 600 grit wet or dry, but I'll just do it a bit more. And these little rubberized blocks are good too. I've got these in a couple of different grades. From where I'm standing anyway, you can see there's a deep mark just there. There's another one just there. I've got to go back and get them out. Alright, let's try the paste. Alright, that's not bad. I'm going to go around and do all of this and then we'll catch up just before we do the nickel plating, and I'll show you that process where we fill those little defects with the soft solder, I should say, and then we'll have a look at the plating. Alright, well that's all of the face of that one done, and that's the easy bit. Doing the inside is the most frustrating part of this. And the main reason is that you have to be able to get into that internal corner, just in there. And no matter how hard I try, I'm just finding it really difficult to get a clean finish right in that corner there. The problem is that the Dremel won't reach in there. Any sort of sanding process you do always leaves little tiny scratches right in the corner, and if you try and do it with a piece of cloth or something like that, the logical thing to do would be to just do that. Even that seems to still leave scuff marks in the corners. So I'll do the best I can, but this is the part that I don't like doing. So I'll turn this around so you can see what I mean. So it's this bit here that gives you the most headaches. This little polishing stick that I'm using is just 800 grit wet or dry wrapped around one of those sticks, as you can see there. And as it wears out, you're left with a strip right on this outside edge which has been well used. You can just cut that off or tear that off and wrap it up again, and you get a fresh piece of wet or dry to work with. However, having said that, the worn out wet or dry cuts less deeply, and sometimes that's an advantage when you're working on these inside corners. If you use brand new wet or dry there, it will cut and leave very deep scratches. Now when I go to polish this, I can do this bit easily, but getting into the corners is an issue. So I can get to within about 2 millimeters of that inside corner, and then you're going to either scratch the brass with the shank of the buffing mop, or if that little screw point on the end there is protruding through, which it is, you can scuff the vertical section up here. So there's a limit to how close you can get, and what I've been doing up until now is I've just got another stick with a piece of cloth, and I just get in there and work it across like that. but the finish is not quite the same. Always looks a little bit scratched in there. I might try using just liquid Brasso right in that internal corner there. Just before I wind up here, there's an area just here which when I did the silver soldering it distorted and buckled and it left a little hole there. I filled that with soft solder and I've given that a preliminary sanding with a slightly coarser abrasive. So you might be able to see there's a slightly dull grey area just there. And of course the problem is that the solder is softer than the brass. So when you start to polish it, it always sort of gives you a slightly depressed surface where that soft solder is. But I can put this piece at the top and hopefully no one's going to see it. So you can see the soft solder quite clearly there. When that's plated, it's going to be way less obvious. I mean, if you look carefully, you're going to see it. But the only other way to fix that would be to use silver solder, which is a bit closer to the same hardness as the brass. But I don't really want to get this red hot again. I might have resolved my problem with that internal corner. What I've done is I've taken this rubberized abrasive block and I've just sanded that on my belt sander. And I've cut that corner to an acute angle just here. So with that block on there now, I can get almost all the way into that corner. Don't know why I didn't think of this before. Because you're an idiot, Mark. Okay, both these now are finished to roughly the same standard. Not perfect, but I can't afford to put any more time into it. The last thing I want to do before I start the nickel plating process is to try to hide the very, very tiny gap between these two pieces of brass. I'm going to wipe on some soft solder to that joint and then just very lightly polish that to hide the last of that joint. And I want to attach a piece of copper wire to the back of the angle. So it's going to go roughly there. And that will allow me to make an electrical connection with this in the nickel plating bath, and then when that's all done I can just break that piece of copper off and just lightly file it. All this internal part of the angle is going to be against the face of the clock anyway, so I'm not bothered about scraping off the nickel in that area. So I've just got my electric soldering iron heating up. I've got some acid flux in here. This is my handy dandy acid flux brush that I saw on Myford Boy's site, and works a treat. It's wonderful because you just wash it out when you're done and it doesn't degrade in the acid flux there. So I'm just going to dab a bit of that on. Alright, this is my old electric soldering iron. Looks terrible but it works. That's my electrical connection for the nickel plating bath, and I can just snap that off later. Okay, give them a polish up. Starting to think I should have done this before I did too much polishing on this part. What can you do? Just doing things backwards again. I'd say that's marginally better. Still visible. I think that's as good as I'm going to get it. The next step in the nickel plating process is to get these parts chemically clean. And this is the one that I just finished buffing, and you can see it's got a lot of black residue on that from the brass polish that I was using. So I took the other one upstairs and I washed that in the kitchen sink just with really hot water and some detergent. And I used one of these little magic sponges, and these are great because they're very, very mildly abrasive, but they also absorb contaminants into the surface of the sponge itself. When it came out of the kitchen sink, I've now put it into this bath here. This is Jane Kitt's Parts Wash, and I bought this as a concentrated solution. You water it down, and I believe it's just like a fairly concentrated detergent. I've got the heater in there as well, just because I thought it might work better when it was hot, and it's coming up to about 40-50 degrees centigrade. And all I'm doing here is just sort of turning this end for end because I can't get the whole thing in the bucket, and just giving it a wipe and a scrub wherever I can get to it. The reason I'm wearing gloves is not because I'm worried about this stuff being toxic. I'm worried about getting skin oil on the brass, and that is going to prevent the plating solution from touching the brass. So this is all about ensuring that the plating solution actually wets the metal when it goes into the plating bath. Even though it's immersed, it doesn't necessarily mean that the plating solution is butting up against the surface of the brass. So if you've got like a waxy or an oily residue there, that's going to prevent that chemical to metal bond, and that means you don't get any plating in that area. Now, the theory is that if you can rinse this with demineralized water and the water doesn't bead, it's ready to go into the plating bath. So if I give that a bit of a rinse, you should see that the metal is wet, right, and no beading is taking place. So if that happens all over, it's ready for that next step. Now this, just looking at that bit there, that looks good. So I'm going to give this a rinse, and then we're going to have a look at it in the bath. This is my nickel plating solution. I've got 4 litres here in this bucket, and this is brand new. I've never tried it before. I bought this from a company called Jane Kitt's here in Australia. They sell solutions and accessories and plating supplies for DIY enthusiasts. They are not a sponsor. I had to buy all of this stuff, but I've always found them to be very prompt with their delivery. Their prices are reasonable, and they've got a good range of materials that I use anyway. Now, I also purchased this. This is a heater which allows you to bring the temperature of this solution up to 55 degrees centigrade, which is the correct temperature. Now, unfortunately, I couldn't buy this from Jane Kitt's. I ended up getting this from Caswell, Australia. But once again, it was reasonably priced, and it's got a variable temperature control on it. I also purchased some new nickel plating anodes, and they come in these, or you can buy these little baskets, putting 5 of those anodes in there. And I've never tried these before either, so I'm keen to see how they work out. Now, my problem is that I can't fit the part that I want to plate in that container, obviously. So I went down to my local hardware store and I scrounged around, and I found this. Now, this is just one of those parts drawers, and it had a series of dividers in it. And that works out to be pretty close to the correct size. And my reasoning is that by keeping the nickel plating bath almost the same size as the part, I can put that into the solution. I've got enough room to fit my heater in there as well and keep that submerged. and I can put my anodes in the bottom, in the center of that frame. That allows me then to pour in that 4 litres of solution and get the depth that I need. If I use a round container or something of another shape, I probably wouldn't have enough that solution to make it work. What I need to do is to just get one of these dividers and stick that in there, and I'm going to use silicone to get a really good bead around that so to make it watertight. When I was mentioning about sponsorship, I should also mention that just the other day I got an email from Banggood inviting me to be part of their affiliate program, and clearly they've looked at my channel and they've seen I've got a couple of thousand subscribers, and I must have clicked over onto some special list that put a red flag against my name, I guess. But look, I politely declined to be part of that process. I did say that I wanted to remain independent and make my own content. And basically I didn't want to sell out like some other YouTubers. Look, I'm sure you've seen enough videos about cheap collet sets and turning tools, and you don't need to see any more. So look, Banggood, if you want to buy me a brand new milling machine or a brand new lathe, I might be interested, but they offered me goods up to the value of $20, and I thought, whoa, I could go and paint the town beige. But that's not going to happen. Anyway, let's get this bath made and get on to plating. How does that look? Does that look like enough? I remember watching a guy doing some shower screens for us, and he said if you put methylated spirits on the job and then run your finger over it, it won't stick to your finger. Apparently methylated spirits doesn't mix with silicone. Now this doesn't look pretty, but it doesn't need to. Alright, that's really thick. It's not like there's going to be a lot of pressure in there, so I'll just let that cure and see if it's watertight. Well, I'm hoping this will give you a sort of a general view about what's going on in here. There's the nickel plating anodes in their basket, and I've used stainless steel tie wire to form a connection with the rectifier. The brass frame sort of fits in there, pretty much filling the perimeter of that tank. The heater's at this end here, and that's now heating up. This is the thermostat that comes with the Caswell heater. You can set that to anywhere between 110 degrees and 140 degrees Fahrenheit. Yep, Fahrenheit. And I've set that to roughly 55 degrees centigrade. When the solution comes up to the correct temperature, that red heating light will go out. Now the other thing I should mention is that I found it really difficult to find any information about the correct current density for nickel plating DIY solutions at home, if you like. I did find a reference to a figure of 1 amp per 80 centimeters squared. Now I don't know if that's correct, but when I did the calculation it came out to 2.46 amps to do that complete part. Now, I know the surface area of this part because I've already modeled this in Autodesk Inventor. And Inventor has this useful thing called iProperties, which you can extract from the file menu, and it will tell you things like the mass of the component, as long as you put the correct material in to start with. You can also work out the volume, the surface area, the center of mass, and a whole host of other useful bits of information about that part. So I worked out that this particular part, or the program told me that this part was 196.8 centimeters squared in complete area. So when I plugged that into the 1 amp per 80 centimeters squared, that's how I get my 2.46 amps, which is the recommended current. Now, I don't know, that seems a bit excessive, but I guess we're going to have to work with that. But I think I'm going to err on the side of caution and start off with something a bit lower, maybe sort of like 1.5 amps, and just see whether we get a plating happening on that part. I'm worried that if you overdo the current, you can get a thing called burning, which makes the nickel go black or dark. And if that happens, you've basically got to remove all the nickel and start again. So I'm going to watch this like a hawk when it gets going. The only problem is it's going to be hard to sort of pull it out of there and have a good look with all that other paraphernalia in the way. But, well, we'll do the best we can. I've just checked that temperature there now. It's 55 degrees or thereabouts. So let's do the big switch on and see what happens. Now this is the power supply that I'm using here. This is a GoFert. I use this one for anodizing as well as doing electroplating. And this one has a maximum of 32 volts and up to 5 amps. So that's pretty much all I need for most of my needs. It's got a handy way of setting both voltage and amperage, so you can determine which one of these digits you want to change and mess around with the voltage and amperage that way. So I'm going to set this to 3.5 volts. I've set it to 1.5 amps, and although my recommended amperage is higher than that, I just want to start with something low and just see what happens. I figure that I can't damage it using too low an amperage. So my positive for this particular operation goes onto the anode. And like I say, just got to be a bit careful that I don't touch these two together. Negative onto the work. Right, nothing blew up, so that's good. It's showing on the digital display here, I got 1.1 volts, 0.162 of an amp, which is strange. That's because I've got it set. I've got it set to 0.15 of an amp. Okay, let's fix that. That's better. 1.5 amps. Now, when I've done this in the past, the nickel plates almost immediately, and if I take that out, yeah, brilliant, that's actually silver. Okay, that was quick. So I believe that 15 to 20 minutes should give you a really thick plating of nickel. In this case, I don't need it to be ultra durable. I just want it to be decorative. If this was subject to wear and tear, I'd be a little bit more careful about using the correct time to get the thickness of plate that I want. So I don't want to run the risk of getting sort of defects in it by leaving it in for too long. So we'll leave this for a few minutes and see how it looks. But so far so good. That's been in place now for around about 10 to 12 minutes. And interestingly, the power supply here never got much over 1 amp. Even though I've limited this to 1.5 amps, never got anywhere near it. That could be something to do with the voltage that I set this to. But like I say, I found it really hard to locate hard information on how to do this. I think I'm going to have to buy that book from Jane Kitts. However, having said that, the project's turned out quite good. I know it's hard to see. I can't pull this out of the tank just yet without dismantling the heater. But that's come out shiny, silver, looks uniform. No real defects that I can see. But let me get this out of here and we'll have another look. I just took that one over the bench and I rubbed that all over with some of that paste polish and just a clean rag. And just about all the defects came out. There were a few patches where it was a little bit rough to the feel. But I rubbed that over with that polish and that seems to have been repaired. There's a couple of funny little defects. Where are they? There's sort of looks like some watermarks on the inside there, and there's a strange little sort of a burn mark just there, and I can't explain why that ended up being there. But I don't know, I reckon for like a home solution, the result you're looking at there is as good as I would have expected anyway. There I can see defects at the corners where the miters are. I can still see the joints between these brass pieces here, but you know, it's for what it is, and for what I was expecting, I'm sort of happy with it. This is the one that's still to go in the plating bar, so that's just the polished brass. I'll get this one in the clock and we'll have a final look at it and then we can move on. But I don't know, I reckon I'm on a winner. Well, there it is, and this is going to be held in eventually just using double-sided tape. So for now, I can tape that in and out as I need to. Now, the other version of this was a bit of a disappointment, quite frankly. It's similar, well, same colour, shiny, but it has little tiny pimples all over the surface, and mainly this horizontal surface here. And I suspect that when I plated this, there were some impurities in the plating bath, and they've settled out on the surface of this part. However, I don't understand the quite distinct difference between the two. So I'm going to buy the plating book from Jane Kitts and do some research and see if I can sort of sort out what I've done wrong. As a way of fixing this, I'm going to try buffing this fairly hard. The nickel is way harder than the brass, so even scrubbing this with one of those abrasive rubber blocks didn't seem to make much of a dent in the surface of that. I have got some 2000 grit wet and dry, which I'm going to try just in an unobtrusive place, just seeing if that can flatten it slightly and then buff it again. As a last resort, I'll clean all of that nickel off, and I might try silver plating this one. I have got one of those plug and plate kits which I've used previously on brass, and it works quite well. So just for a different version, I might try the silver plating. But at a distance, that still looks quite acceptable. But if you get up close, you can see the defects in it. So I'm going to finish this video here. In the next episode, we're going to start putting all the guts inside this, which means assembling all of the Lixie units and testing those, make sure they work properly. We've got to get the ESP8266 microcontroller fitted inside and make all of the associated wiring for that, so I can plug in all of the various modules and make sure everything's working. And there's a few little finishing touches that I'll put on both clocks, but look, for what it is, I'm happy with that. I reckon that looks good. So we'll catch you in the next episode. Oh, and we're going to make some nipples as well. Now stop sniggering. They're actual parts made of brass that hold the various pieces of the Lixie units together. So just stop those smutty thoughts straight away, will you?